So a couple of the key security concerns, and you may be familiar with a few of these, but as they pertain to cloud, Gartner, the bunch of smart folk that they are, they did a couple of surveys specifically aligned to security, and this was done last year. And of course, some of the big security concerns that came out of that one is there is a patchwork of security solutions out there. People are still fundamentally trying to apply things like physical appliances or like traditional approaches to this new world of virtualization and cloud. And not surprisingly, it's introducing a lot of complexity, a lot of fragmentation, and a lot of time in trying to bring services to the market. We have a look at how we're actually securing applications and data. And the interesting thing from this is that everyone understands the concept of an air gap. How do you get an air gap in a virtualized infrastructure? Any takers? Pretty challenging, right? Generally speaking, one of the things you really can't do. So what we have to move to are things like virtual separation and trusted zones. And these are the things that it's not a new concept as such, and we're seeing it far more mainstream now. But for people like the Department of Defense in the US and other large institutions to be able to use these things, obviously they get it and it works. So it's not something to be afraid of. It's absolutely an enabler to realizing these efficiencies. The last one is around IT compliance. Now, whether that's configuration management in the context of your own internal standards, or whether it's compliance in the context of regulatory compliance like HIPAA or PCI, all those usual standards, the perception is that, oh, I've gone virtualized or cloud, I can no longer bring those sorts of controls to the environment. Not entirely the case. If anything, we're actually simplifying it because we can do it across a broader scale in a shorter period of time. So it's around perception changes as to what these groundbreaking technologies and the evolution of these technologies can actually bring to make your life, once again, quite a bit easier. Also trying to apply static measures in a dynamic environment. When we talk technology, and yes, I work for a software vendor, but this software is one thing, the tools to manage are one thing, but the fundamental change in the pieces, that was a good merging word, the people and process that's aligned with these security practices. It's not just a technology story. You have to embrace all three. So what is the software-defined data center and how do I secure it? So who's heard of our software-defined data center approach? Whether you've read it in the market, a few people there, probably been to a couple of our roadshows. We do run a couple. So the long and short of it is it's an infrastructure where everything is virtualized and essentially everything's delivered as a service and it's all driven and automated by software. This sounds pretty straightforward, but I'll make it even easier. If we go through and have a look at what we did with this little guy, it's a CPU, okay? What was the one thing that we did that made life wonderful? Partners were able to build massive businesses around it. There were rainbows, there were unicorns, famine was abolished, all that sort of stuff. Pretty amazing. Customers did actually save billions of dollars in CapEx and OpEx by deploying these technologies just at that level. So what we did is we abstracted, okay? It's made a lot of sense. So what if we were to apply that same abstraction to other components of the data center? Like your storage, for example. How about your network environment? How about things like, oh, hang on a minute, security, whether it's intrusion detection, firewalls, whatever that might be. And of course, not to be forgotten, the tools, the people, and the process elements of it. What if we were able to take all those and build those into a software construct? Because what happens when you build something into a software construct? It becomes more flexible, more agile, easier to manage, in theory. We'll put it in practice. Now, you've got more than one of these things in each of your data centers, right? Obviously, a data center with one computer in it, maybe we'll get there one day. I don't think quantum computing's in the mainstream just yet. But as far as it goes, we tend to have multiple silos of these things kicking around. Now, whilst you've got siloed IT, and I do touch on this a little bit later, but what is one of the things that you can't do? You can't scale. Or you can't scale effectively. So if you can't scale effectively, how do I expect to keep up with the demands of the business? So in order to bring granularity of control and scale to the environment, we have to look at things like pooling. So bringing all these components together in their respective pools, categorizing them, whether that's from a level of service aligned with a tier, or a level of performance or availability required from storage, or maybe it's a particular set of access controls and compliance standards, okay, on that networking and security side. So that's the next key, to pool the resources, because when you bring everything together, you have a larger resource pool to pull from, so you have a common infrastructure, but then I'm also very good at carving off the bits to the applications that I need while still guaranteeing their service levels. All right, these are some of the tangible outcomes that you'll get from the software-defined data center approach. The last thing to do is to actually automate. And automation is often a concept that's misused quite readily across the IT industry especially. So a lot of people confuse it with orchestration. So How many of you fine ladies and gentlemen out there today have an orchestration engine running the core of your IT function today, i.e. scripting? A lot of scripts in the environment? Don't be afraid. Yeah, it's quite an interesting thing because scripting is great. Usually revolves around the concept of an engineer sitting there one day thinking, you know what, I can do this in a far better way. So they beaver behind their console and they generate all these scripts and it's amazing. They say, yes, look what I can do. And basically it's a script that hits next based on some conditional formats and logic. The challenge with that is what happens if said engineer leaves after 5 years' time? Documentation hasn't always been an engineering strong point. And you tend to miss all the things that were done and all the elements of this script actually touching. So what you end up having is a rather brittle and frail integration of components that if you choose to maybe grow and expand your infrastructure and all of a sudden an API change or something else happens, all of a sudden the scripting breaks, your orchestration falls over. The number of other vendors out there that are talking the construct of cloud via orchestration, it's a very shaky foundation to be on. And orchestration is typically tied to hardware. Right, that's the biggest downfall. What it does is it hides complexity. If you have a look at automation, automation is actually done as part of the machine. It's actually part of the tool set in the portfolio. So when you look at it from that perspective, automation is tied to software. It's tied to virtualized assets. And what it does, it doesn't hide complexity, it actually eliminates complexity. Okay? Abstraction helps us do that, and that's why with a combination of abstraction, pooling, and automation, you actually have a very solid foundation and you can move to the software-defined data center quite readily. So of course, the next thing is what you actually have a look at from an efficiency perspective and what you get out of this. So by bringing all these together, what we do is we carve this together in something called the software-defined data center, where all of these services are now defined by software. And you'll see a term in there called a VDC. Who knows what that is? A virtual data center. Never saw that one coming, right? Amazing. So virtual data centers are a pretty incredible construct because they can be aligned to a number of different things, whether it's a business unit, whether it's a complete organization, maybe of course it's a development life cycle or even a tier of service. Let's say it's a bronze, a silver, a gold, a platinum, whatever that might be. So the benefits around creating and policy defining all of those different elements across the data center is that it's two things. As soon as I get to deploy a workload into one of those containers, they inherit via automation all of those characteristics that actually makes them a service. This sounds pretty compelling, right? We're getting away from this paradigm where, you know what, to spin out a virtual machine, it was, it's amazing. It cost, $300. It took 2 minutes and it was there. And you went, wow, that's incredible. And they're prolific little bastards as well, I've got to say. VM sprawl is still a big problem today. VMs are so easy to create. We just looked at the VM. We always had to wrap around all these other services. And so what was 2 minutes and $300 turns into like 5 days and $1,800 plus all the other peripheral stuff on top of that. So this solves a genuine problem. The other problem it actually solves is it gets you away from this silos and IT approach. So the idea is that I no longer need a silo for my Windows environment, and that's what we're talking on to now, a silo for perhaps my Linux infrastructure, also a silo for all the other various things that I need to do. Wouldn't it be cool if I could have completely disparate workloads with different workload profiles, but have them across a common infrastructure? That sounds pretty compelling, right? Sounds like I can actually use this pooling and automation to a degree to deliver and guarantee service levels to what it is I'm trying to deliver back to the business. So this is what we're solving for, and the payoff is again largely around the efficiencies. So we go to be able to deploy a complete service at the right level of security, right tier of storage, and all the availability, so on and so forth, in minutes and seconds, versus what it used to be with virtualization. And yes, don't get me wrong, rainbows and unicorns aside, it did actually save a lot of time in this and effort involved in spinning out a workload. But we're going from days and hours, and which is a far cry and improvement from what we had to do in the physical world. Who still deploys physical workloads today? We know there's a couple out there. Yeah, there you go. 10 weeks, 10 grand, you receive the gear, it's on a pallet, you rack it, you stack it, you cable it, you load up the operating system, you test it, you burn that in, you put the application on there, populate it full of data, do some more security wizardry around that side of things, and then you might be up and running to be able to do some testing on it. Big difference. Virtualization solved a lot of problems and cloud goes even further, but you can't do it without the awareness on the security part. So I'm trying to avoid this becoming a product pitch, and I'm going to do my best to avoid that as well. But the long and short of it is we have a suite which gets you to the path of the software-defined data center in a fairly concise way. And there's a lot of elements to that one. Obviously, you've got still the physical server and storage that underpins it, and this can be multiple vendors. We have a large compatibility list that drives to that. vSphere is that virtualized foundation. It is still the world's best hypervisor by a long shot. We have obviously the software-defined storage and availability, things like Site Recovery Manager. Who uses Site Recovery Manager today? That is a wonderful product. One of the biggest things that brings benefit to is runbook automation. How long does it take you to test your disaster recovery policy? Sorry, let me rephrase that. Can you test your disaster recovery policy without a lot of heavy lifting? Very few people can. And there's usually a large binder of notes that's associated with that one. A large binder of notes and manual processes introduces one really bad thing, the potential for human error, which is still where the vast majority of problems come from today. So if you can automate that runbook and be able to hit the big red button to test it repeatedly and on demand, that's pretty compelling. That's what you get out of that stack. And there are new platforms that you'll see coming out later this year based on some acquisitions that we've made that really go a long way in pushing the network virtualization side and also the storage virtualization side as well.